Now that we have seen what combustion is, let's study about ignition, about that ignition temperature that I was talking to you about, and we'll also be learning about the three requisites that are there, the three conditions that are there for combustion to take place. The ignition temperature, if you remember of what I was explaining you earlier, it is that lowest temperature at which a substance catches fire. Alright, so not every substance catches fire at room temperature. For the substance that catches fire at room temperature, it is stored in a very in a very cautious way so that it's not exposed to outside air. And for those substances that do not catch fire at room temperature, some source of heat is some source of heat, some source of temperature is provided to them so that their temperature is increased and they'll finally reach that temperature at which they are able to catch fire on their own, and they do not need the supply of any external source of fire. Okay, so the ignition temperature is that temperature, that lowest temperature at which a substance is able to catch fire on its own, is able to combust on its own. Okay, and combustible substances, they cannot catch fire or burn as long as its temperature is not reached this lowest temperature. All right, kerosene oil and paper, if you remember, they have a very low ignition temperature, whereas wood, it does not catch fire on its own at room temperature. So we provided that kerosene source of burning kerosene oil or paper to that piece of wood. But if kerosene oil is heated a little, only a little, we know that the ignition temperature of kerosene oil is very low. So if you just provide some source of heat to kerosene oil, it will burn on its own. It will catch fire and it will combust on its own. All right. Why a matchstick does not catch fire on its own at room temperature? Because the source, or you can say the ignition temperature of a matchstick is not is higher than the room temperature. All right, but if you start rubbing that matchstick towards this end, all right, that is they're provided in a matchbox, then you will observe that immediately a fire is burnt, immediately a flame comes up. All right, and in the next slide we will be answering that second part of the question, that is why does the matchstick start burning on rubbing it on the side of the matchbox. So what happens is that there are some chemical depositions on the head or on the tip of the matchstick as well as on the surface of the matchbox. Okay, so the surface of the matchbox, all right, it contains red phosphorus, and there is a very distinct property, or there is a very distinct characteristic of phosphorus, and that is phosphorus burns readily in room temperature. And there are two kinds of phosphorus, red and white, but red phosphorus is a little less flammable than the white phosphorus. So in this working of a matchstick, you will be learning that how exactly, what the chemicals that are used and how exactly a matchstick catches fire. Okay, so the tip of the matchstick, it contains antimony trisulfide. This is a flammable combustible substance and this will burn. And how this will burn, let's find out. The rubbing surface, the surface of the matchbox, it has some powdered glass plus this red phosphorus. All right, some powdered glass to provide friction and this red phosphorus. When the match is struck against the rubbing surface, what happens is that some red phosphorus gets converted into white phosphorus, so that this red one is getting converted to the white one, and the white one, if you may remember, is a much more flammable substance and it burns easily at room temperature. Okay, this immediately reacts with potassium chlorate in the matchstick head. This matchstick head, this tip of the matchstick head, it has two chemical compounds. It has antimony trisulfide, which is a combustible substance, and it has potassium chlorate as well. And the surface of the matchbox has the red phosphorus and the powdered glass. So when you rub this tip of the matchstick against the surface of the matchbox, the red phosphorus gets converted to white phosphorus, okay, which is highly flammable at room temperature. And this white phosphorus, this reacts with potassium chlorate. Okay, this white phosphorus, this reacts with potassium chlorate to produce enough heat. This white phosphorus reacts with potassium chlorate to produce enough heat so that our combustible substance antimony trisulfide reaches its ignition temperature, and finally you see this flicker of flame in your matchstick. I'm repeating this again. The tip of the matchstick contains potassium chlorate and antimony trisulfide. Antimony trisulfide is a combustible substance, and the surface of the matchbox contains other two substances, chemical compounds. They are red phosphorus and powdered glass. Now, phosphorus is flammable at room temperature, but there are two kinds of phosphorus, and out of them, the white one is more flammable than the red phosphorus. So, on the surface of the matchbox, there is a less harmful substance, the red phosphorus. And when you rub the tip of matchstick against the surface, the red phosphorus, it gets converted to white phosphorus. This white phosphorus reacts with potassium chlorate that is present at the tip of our matchstick. And when they react, heat is produced, and this heat is enough for our antimony trisulfide, for a combustible substance, to reach its ignition temperature, so that you observe a flicker of flame on the matchstick. This is how matchstick burns, and this is why matchstick does not burn on its own at room temperature unless you start striking the tip of the matchstick with the surface. Now, is ignition temperature necessary for burning? We will be looking at another requisite that is required for combustion or burning. Okay, so here for this experiment, you have taken paper cones, all right, paper cups of paper cones. Okay, and you have folded this where you have folded it as a sheet of paper, and then you pour about 50 milliliter of water in one of the cups. You have suspended it like this, and you have poured some water in one of the cups, and the other cup is dry. Then you bring both these cups towards a source of heat, towards say a burning candle, all right, and you will observe that the dry paper, it catches fire immediately, whereas the paper that was wet, it does not catch fire. Rather, the water, it starts getting warm, it starts getting hot outside. All right, so the water inside the cup, it becomes hot, whereas for the other setup, which was only our paper cup, the dry paper cup, it catches fire immediately. So what happens is that the heat supplied to the paper cup is transferred to the water by conduction. You know that since water is present there, and water is a good source of conduction as well, so the water will start getting hot and the paper will not catch fire. All right. Whereas for the dry paper cup, there is no water and the paper will catch fire immediately. So in the presence of water, the ignition temperature of paper is not reached, because water is cool as compared to say a dry paper cup. All right. So water hinders the ignition temperature of the paper the water hinders the temperature of the paper cup to reach its ignition temperature. All right. Water hinders the temperature of the paper cup to reach its ignition temperature. Whereas in the dry case, in the dry paper cup, there is no water, there is no other cooling agent to hinder the paper to reach its ignition temperature. So its ignition temperature will be reached immediately, and the dry paper cup will start burning, whereas the paper cup that was holding water, that won't burn. Okay. Now, there are some substances like kerosene oil, like paper, whose ignition temperature is very, very low. It's so low that as soon as you provide some source of heat, it starts burning. And those substances that have very low ignition temperature, we have a name for them, that is inflammable substances. You must have seen this disclaimer sticker on, say, alcohol, on, say, the deodorants that you wear. Okay. So inflammable substances are those substances that have very low ignition temperature. So you have to keep in mind that you do not bring those substances near to fire, near to any source of heat, because if you do so, it will immediately reach its ignition temperature and will start burning and will cause a fire. Okay, so these substances can easily catch fire with the flame. All right, and examples of inflammable substances are your petroleum products, petrol, alcohol, liquefied petroleum gas, etc. Okay. Other inflammable substance apart from your petroleum products could be your deodorants, because your deodorants also contain some liquids or some obviously when you spray, gas comes out. So whatever liquid gas particles are there inside your deodorants, they are inflammable substances. If you have a chance to look at the base of your deodorants, usually it's there at the base, or sometimes it's also there at the sides. all right, where you have the product description. It's written there that it is inflammable, and a picture would be there that, this kind of picture means it is indicating you that you should not bring that deodorant, all right, you should not bring that to and you should not expose it to any source of heat, to any source of fire, otherwise it can catch fire. Okay, then the paint thinners that you have, those also contain inflammable substances. Okay, and the other product that you use, which you can easily observe, is nail polish remover. All right, if you use, or your mother uses, or anyone of you, anyone in your family, if they use nail polish, and if they have nail polish remover, or if you have nail polish remover at your home, you check the bottle, you check the description of the bottle, and you'll notice that there also is such kind of sticker and a disclaimer that this is an inflammable product, so you should not bring this to any exposed heat, otherwise it will catch fire. So now we have established our three requirements, our three requisites in order to produce fire, or in order for combustion. Okay, and what is this? This is a triangle that we are forming over here: oxygen, heat, and fuel. Fuel, whatever kind of fuel you're using, be it to bags, be it your petroleum products. Okay, they are those substances, those combustible substances which will catch fire and which will burn, which will undergo a chemical reaction readily to produce heat, energy, and sometimes even light. Okay, so fuel is the product which will undergo this chemical process. So obviously it is a requirement. The next requirement is oxygen, because we have demonstrated via experiments that oxygen, air is necessary, and in the absence of air you would not get a fire. All right, and the next is your ignition temperature or your heat. So that fuel substance which you are taking, that has to reach a minimum temperature, that has to reach this minimum ignition temperature, so that it starts burning on its own. All right, so that no external source of heat or external source of any temperature is required. So you know that you require fuel, you require air to supply oxygen, and you require heat to raise the temperature of the fuel beyond the ignition temperature, so that it starts burning on its own. And fire, if you want to control fire, if you want to extinguish fire somewhere, you can easily block, or you can easily eliminate one of these requirements, and the fire would be stopped. So like we are seeing in the case that when clothes of a person, they start catching fire, so you can cover the person in a blanket so that the source of oxygen is eliminated. Okay, so you can either remove oxygen, you can either lower down the temperature of the product, so that its temperature recedes, and it reaches below the ignition temperature of the respective product, and so that it stops burning. All right, or if you can just, you know if you can get yourself to get rid of the fossil fuel, or any kind of fuel that you're using, any kind of combustible substance that you're using, if you can get yourself to eliminate that product in the first place, then of course there will be no fire. Okay, so these are the three requirements of reducing fire, and if you were to extinguish fire, you just have to get rid of any one of these requirements. Okay, does your city, town have a fire brigade station? This is a question for you. If it has, then you can try to find out the number of the fire service in your area, so that if there is a fire in your neighborhood, you can immediately ring up at the fire station, and you can call up a fire brigade and get rid of the fire. Okay. When a fire brigade arrives, what does it do? It pours water on the fire. You must have seen, this is a typical figure of a fireman, and this is the fire. This is the hose that he's carrying, and out of it water is coming out. So water is used as a very readable source, a very convenient, a quick source in order to get rid of fire, in order to extinguish fire. All right, because water cools. If you remember that paper cup experiment, water did not let the ignition temperature of the paper cup to be reached. So since the temperature was low all the time, the paper did not reach its ignition temperature, even though paper is quite inflammable, and instead the water started conducting fire. All right, so water cools the combustible substance. Okay, it lowers down the ignition temperature. It does not let the ignition temperature be reached. Or in the case of already when there is a burning fire and when you pour water over it, you are basically trying to lower down the temperature of the fuel so that the temperature goes down. It goes down than the product's ignition temperature. This prevents the fire from spreading. However, you have to be very careful when you're using fire as a source of extinguisher when you're using electrical equipment, and you will be seeing why. Okay, but for now you remember that water cools the combustible substances. It brings the ignition temperature down so that you are removing the heat element, you're removing the temperature element, one of the requirements that is required for combustion, and hence you will be able to extinguish fire. Fire extinguisher, you can some of you must be having fire extinguishers at your home, or you must have seen fire extinguishers if you visit some places, be it some public places, be it some cafes, etc. Okay, so fire extinguisher, it looks like this. It's like a red cylindrical item, and it is an active fire protection device. Means in case of a small emergency, if you have a small fire occurrence, if anything catches fire in your nearby area, and it has not yet reached to such a big fire, that means the fire has not is not so huge that you need to call a fire brigade. All right, so for in cases of small fire, okay, small fire, all right, in order to control that, you have this equipment that you can use it on your own in order to extinguish fire. The job of a fire extinguisher is to cut off the supply of air or to bring down the temperature of the fuel, because the fire extinguisher does both, and also you'll be seeing why. It cuts down the supply of oxygen or the supply of air, and it brings down the ignition temperature. Okay, so you are removing both the elements from the triangle. Remember, we have this fuel, we have this oxygen, and we have this heat or your temperature. So when you use the fire extinguisher, you are getting rid of oxygen as well as you are bringing down the temperature. So immediately the fire will be extinguished. And this is used in cases of small fires in order to control, locate, or limit the small fires. Now, like I told you, water is generally a very good fire extinguisher, and fire brigade, they have tons and tons of water in their trucks, all right, and they use it via that heavy hose. Okay, but in cases where you have a fire caused due to burning of oil, all right, when oil tankers, they get spilled in ocean bodies and they catch fire, so you cannot use water to extinguish that, because as you can see here in this picture, the fire is already burning on top of water. And you know the reason why, because oil, the density of oil, it is lower than that of water, so the oil always floats on top of water. So when oil will catch fire, it won't burn amidst water. It will rather be on the floating surface of the floating film of oil that is already there on top of the water. Okay, also in case of electrical equipments, when any of your be it at your own place or be it in your neighborhood or any other area, if you find out that the source of the fire is electricity, okay, if the source of fire is electricity, then you won't be using water as a source of extinguisher. Why? Because water, it is has the stable element, right, H2O, but water is the good conductor of heat as well as electricity. Means that if water were to pass through a very heavy source of electricity, then that electricity would cause this stable water molecule to separate. All right, it will ionize. All right, it will ionize, and it will cause the stable molecule of water to separate, to break down into hydrogen ion and oxygen ion. All right, into hydrogen ion and oxygen ion. And when that happens, they have since they have a deficiency of electrons, so they will become free electrons, and they will be capable of conducting electricity. They will be able to conduct electricity. So that is why when the source of fire is an electrical source, you do not use water, rather you use carbon dioxide, which we'll be learning here in the next slide only. Okay, so to douse the fire, to extinguish the fire of that is caused by an electrical source, you do not use water. Why? Because the electricity can cause the stable water molecule to break down into particles, into ions. It will basically ionize the water. It will form ions to form out of that stable compound. Okay, and these ions, since now they have a valency, now they have a deficiency of electron, they will start rotating, they will start conducting electricity. So if you were pouring water over a fire that hasn't caused due to electrical equipments, that wire on coming on contact with the electrical source, open electrical source, will conduct electricity, and ultimately that conduction will be so rapid, it will be so fast that you would be getting an electric shock immediately, and it might not be safe for you. Okay, so yes, that is why fire is a good water is a fire good extinguisher. Yes, but you do not use water in case of fires that have been caused due to electrical source. But what do we use instead then? We use carbon dioxide, because carbon dioxide, it is heavier than oxygen, and of course, for a fire to start burning, you need oxygen, you don't need carbon dioxide. So if you're cutting down the source of oxygen by introducing carbon dioxide, okay, towards the immediate surrounding of that fire, so you are getting rid of one of the requirements, all right, and therefore you are extinguishing, you're dousing the fire. So remember this triangle: fuel, oxygen, and heat, all right. And if you remember that a fire extinguisher slide, we had discussed that fire extinguisher not only cuts down the supply of oxygen, but it also lowers heat. Okay, so what happens is that fire extinguisher, they have liquid carbon dioxide inside it, contained in very high pressure. Liquid CO2 in very high pressure. So when the valve is removed, when you lower the pressure, when you pump out the carbon dioxide, so you're basically introducing this liquid from a high pressure to a low pressure. So what will happen? The liquid will be converted to gas. It will expand, all right, because obviously gases have much more spaces between the particles. The gas, carbon dioxide, will expand, and it will occur from a high pressure. It will come, basically it will pass from a high pressure to a low pressure, all right. And what will happen? The immediate spread of carbon dioxide is then going to cut off the water from the surrounding, and it will also bring down the temperature, so that both of the elements are getting rid of, all right. So carbon dioxide is the best extinguisher because it is heavier than water, and also if you're using it on electrical, in cases of fire that are caused by electrical equipment, then since you cannot since you cannot use water, because water is a good conductor of electricity and electricity can ionize water, you are using carbon dioxide. You may use carbon dioxide. It's safer to use this fire extinguisher because it won't get ionized, it won't conduct electricity in the same way that water does, all right, and hence you can get rid of the fire. And there is a fun fact for you: the added advantage of carbon dioxide is that in most cases it does not harm the electrical equipment. So you are getting your electrical equipment intact as well, and also you're getting rid of the oxygen, getting rid of the heat, and this carbon dioxide is also not getting ionized. It is also not conducting electricity. So all your purposes are solved. How do we get the supply of carbon dioxide? I've already explained you, but let's go over it again. It can be stored at high pressure as liquid in cylinders, and when you lower the pressure, when you basically pour out, when you press the knob, okay, so you are introducing this liquid carbon dioxide to enter a low pressure area. So of course it will come out in the gaseous state, okay, and when it comes out in a gaseous state, in a liquid state it is already very cool, all right. So obviously when it is coming out in a gaseous state, it will be cool, and it will be cool enough to bring down the temperature, all right. So it is not only spreading enormously in volume, since it is now in the gaseous state, it is also cooling down the temperature. So it is not only forming a blanket around the fire, getting rid of the oxygen, rather it is also bringing down the ignition temperature. And in some cases where you won't have the access of carbon dioxide immediately, then you can use a dry powder of chemicals. Chemicals like sodium bicarbonate, that is your baking soda, or potassium bicarbonate. When you release a dry powder of chemicals like this near the fire, they give off carbon dioxide gas, and then again the carbon dioxide gas can help can form a blanket, and it can help the element of oxygen to be eliminated, or to basically get rid of oxygen from the source of fire. Alright, so in the absence of carbon dioxide, powders, a dry powder of chemicals like sodium bicarbonate or potassium bicarbonate can also be used. So this is what you learned here in this part of the chapter, ignition. We learned about ignition temperature. We learned about the three requisites of combustion for fire, that is fuel, oxygen, and of course your heat or your ignition temperature. And we learned ways of extinguishing fire. Water is your first choice, but water cannot be used on electrical equipments because it is a good conductor of electricity. It ionizes. So what do we use in place of water? We use carbon dioxide. Carbon dioxide is being stored in fire extinguisher, those heavy cylinder bottles in liquid form. So when it is spreading over a fire area, it can easily cut the oxygen supply as well as it can bring down the temperature. And if you don't have the access to carbon dioxide, you can easily use chemical powders, dry powders like sodium or potassium bicarbonate. In the next part of the chapter, we will be discussing about flame and fuel.